Let's take a look at the two-sample t-test for each of the three scenarios in the receipt message and tip amount experiment. So I've gone ahead and set the alternative hypotheses for each of these three scenarios. I have good weather has a higher tip than bad weather. Good weather has a different tip than no message, and bad weather is worse than no message. So I've filled in most of the two-sample t-test for you so you can start to get a sense of how it will work. There are a few places you need to fill in, and I'll point those out as we go along. So let's look at our first pair, good weather and bad weather. So the P in phantoms is given to us. We're testing the claim that the mean tip for good weather is more than the mean tip for bad weather. So you'll notice here that the word mean shows up twice. And it should show up like that anytime you're doing a two-sample t-test because you have two separate groups and each group has its own mean. So in your conclusion statement, you should also have the word mean in there twice as well. All right, so let's look at our hypotheses. My null hypothesis here is that the mean for the good minus the mean for the bad is equal to 0. So know that that's a little bit different than what we just looked at. So let me explain how we get from what we just did to this hypothesis. So originally we said that our null hypothesis is that the means for the two groups are roughly equal. If they're equal or roughly equal and we subtract them, we should get a number that's 0 or very close to 0. So that's where I'm getting this mean of the good minus the mean of the bad is equal to 0. Because they're supposed to be roughly equal, when I subtract them, I should get 0. I always use the same number for both my null and alternative hypothesis, so that's been set. And then what I chose is that the mean for the good minus the mean for the bad is greater than 0. And I chose the greater than because we're thinking that the good one is going to get you a bigger tip. So if I have a bigger number and I subtract a smaller number, I should end up with something positive. So there's my greater than. And greater than tells you that this is going to be a right tail test. There's a spot to put right tail test in your notes, so go ahead and fill that in. The next part of phantoms is our assumptions and conditions. These are going to be very, very similar to what we did in chapter 20 with the one mean t-test, except that you have to do this separately for each group. So you kind of have to do the assumptions and conditions twice. So we'll start with our good weather group. We had that our random sample, we don't know that we have a random sample, so I put not stated. We've already looked at the normal probability plot, and so we know it's normal. And then I calculated the standard deviation as 1.959. So there's our good weather group. And then we have to do the same process all over again for our bad weather group. So our bad weather, again, random samples not stated. We've looked at the normal probability plot, and that was good. And then I calculated a sample standard deviation here of 2.09. So you notice they have S is equal to, and that's because we're calculating these from our sample, so we're going to use that letter S. Now, because I have two completely separate and distinct groups, I have a two-sample t-test. I went to Excel and I calculated our test statistic as t is equal to 6.29. For our p-value, you're going to see I have two different p-values listed here on the slide. I have p is equal to 1.12 times 10 to the negative 7, and p is equal to 2.35 times 10 to the negative 6. So the reason that there are two p-values here is that there are actually two different ways you can calculate a p-value for a two-sample t-test. The first one that's listed there, 1.12 times 10 to the negative 7, is an exact p-value. And I calculated that using the data analysis package in Excel, and I'll show you how to use that. The second number, 2.35 times 10 to the negative 6, is calculated using the spreadsheet that I set up for you guys with the one mean Z and the one mean T and all of those tabs on there. And it's called the conservative approach. So basically the difference here is they're calculating the sample size a little bit differently in order to figure out their degrees of freedom. And so that's where we're getting just a slightly different answer. Either one of those is fine. You're welcome to use whichever approach is more comfortable for you to use. Both of those, though, that 10 to the negative whatever number that's there means 0.0000. So really, really small. Definitely less than our 5% alpha. So we do reject our null hypothesis. So you want to fill in do reject in your notes. And then the conclusion statement you need to fill in as well. with a p-value of 1.12 times 10 to the negative 7, at the 5% significance level, we do have sufficient evidence the mean tip percentage with good weather message is greater than the mean tip percentage with the bad weather message. You'll notice I have the word mean in there twice in my conclusion statement, and that should always be the case when you're doing a two-sample T. All right, we have two more pairs to look at. We have the good weather versus the no message and the bad weather versus the no message. What I'd like for you to do is pause the video, go through and fill out which tail test it is, whether you do or do not reject, and fill in that conclusion statement, and then we'll go through them together. All right, so hopefully you gave those a little bit of a try and look through them. For this one, we're testing the claim that the mean tip for the good weather differs from the mean tip for no message. My null hypothesis stays the same, mean of the good minus the mean of no message is equal to 0. My alternative is that the mean of the good minus the mean of no message is not equal to 0. So I'm getting a two-tail test there because all they gave us was a differs from. It's not giving me a sense of direction. So I used a not equals to and a two-tail. Again, for our assumptions and conditions, we do have to do those for each group separately. We already did the good weather one, so I went ahead and wrote it down on the slide. And then for the no message receipt, again, we didn't have a random sample. We've already looked at the normal probability plot and it was good. And our sample standard deviation here is 2.388. So that's kind of the biggest out of all three groups. Because once again, these are separate independent groups, we have a two-sample t-test. My test statistic from Excel was 5.06. And then the two p-values, I had either 0.0001, that's the exact one, or the conservative one is 3.53 times 10 to the negative 5. Both of those, again, are really small, so less than our 0.05 alpha. So we do reject our null hypothesis. And with a p-value of 0.0001 at the 5% significance level, we do have sufficient evidence the mean tip percentage with good weather messages differs from the mean tip percentage with no message. So just taking that again from my alternative hypothesis. And then our last pairing, bad weather versus no message, we were given that we're testing the claim the mean tip for the bad weather is worse than the mean tip for no message. So my null stays the same, the mean of the bad minus the mean of no message is equal to 0. My alternative, the mean of the bad minus the mean of no message is less than 0. And I got a less than because we're saying that the bad weather is supposed to be worse. So it's going to be a smaller number. And when I subtract that, then I end up with a negative number. So I chose the less than to reflect that, less than 0, which gives me a left tail test. Our assumptions and conditions, again, we're checking these for each group. We've already done that for both the bad weather and the no message, so I just went ahead and copied those onto the slide. Our two distinct groups give us a two-sample t-test. I have a test statistic of negative 0.77. And then my p-values here are actually very, very similar. I got about 0.22 for both of those, so about 22%, which is really big for a p-value. Definitely bigger than our 5% alpha, so we do not reject our null hypothesis. Meaning that with a p-value of 0.22 at the 5% significance level, we do not have sufficient evidence the mean tip percentage is worse or less than the mean tip percentage with no message. Okay, so there's kind of our three conclusions. And if we go back to looking at our box plots, those results should make a lot of sense. The good weather versus either the bad weather or no message is a pretty big jump. Hence, we got the do reject. There is a difference there. The bad weather, the no message, that X there or the mean is very, very similar. And that's where we got the do not reject. Those means are just simply too close to each other. All right, so that's our two-sample t-test. I will tell you that there is another test called an ANOVA test that allows you to do all of these comparisons all at the same time. So rather than running through each pair on its own, there is another way. And if you took another stats class, they'll get into how to do that.